Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Zipperbug by Mello Robinson, and here are the rules. Normal Sudoku rules apply, which means fill the grid with the digits 1 through 9 such that there are no repeats in any row, column, and box. Digits in equal distance from the marked center of a purple line have the same sum. Digits in a cage, so let's start with that. This is called a zipper line, where basically digits that are the same distance from the marked center of a purple line have the same sum. This one we can tell easily because we have cages here, but basically these two digits must add up to 6, and that's by the cage. Okay, so let's continue with the cage first. Digits in a cage do not repeat in sum to the total if given. So that means these two digits must sum to 6 because they are in a cage. That means those, but they're also equal distance on a zipper line. So therefore you know that any two digits on the zipper line must sum to 6. So these two digits must also sum to 6. These two digits must sum to 6. These two digits must sum to 6. And these two digits must sum to 6. And that's the same for all the zipper lines, right? These two digits sum to the same sum. These two digits sum to the same sum. And these two digits sum to the same sum. And that's how zipper lines work, and that's how cages work. And we usually call them killer cages. And then the final rule of this puzzle is gray squares contain even digits. So these gray squares must contain an even digit. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, as I stated earlier, these two digits must add up to the same sum. So they add up to 6. These two then must add up to 6. Same with these, and same with these. Well, we know digits in a cage do not repeat. And the only digits that can add up to 6 are the digits 1 through 5. Actually, this doesn't help there. That's not a good thing to focus on, I guess. We do know these 4 digits must add up to 6. So they have to be the digits 1 through 5. So let's mark that there. That means similarly, these digits must be the digits 1 through 5. And these have to be different digits from each other. These digits can only be 1, 5, and 2, 4, because 3 would have to add up with itself to add up to 6. We know this is an even digit, so it can only be 2 or 4, and the corresponding digit on the zipper line has to be here. So this is also 2 or 4 to add up to 6, right? Well, in this column, we now have a 2, 4, 2, 4 pair, which eliminates 2 and 4 in the column. So this can't be 2 or 4. This can't be 2 or 4. So, and, well, this one we don't know. We do know that these two cells must add up to 6. And one is odd. The other one has to be odd because 6 is an even number. You need 2 odd digits to add up to 6, or 2 even digits. You cannot have 1 odd and 1 even. So similarly, this must be an odd digit. So let's mark the odds and evens, because that might make things easier. Okay. These digits add up to 7 because of the killer cage. and therefore any two digits that are equal distance away from the from the center must add up to 7. Well, the only digits which can add up to 7 are 1 through 6, right? So this is 1 through 6. These are 1 through 6, which tells us a lot of information, actually. We now have in this box a 1 through 6 sextuplet, which means that the other digits in this box cannot contain the digits 1 through 6. So these have to be 7, 8, or 9. Also, in this box, where is the 6? It has to be one of these two cells. Well, in the corresponding cell in the zipper line, there has to be a corresponding 1. So because there's a 6 in one of these, there has to be a 1 in one of these to add up to 7, right? So this is 6. This must be a corresponding 1. Do we have any other information? Not for that one. These two digits must be different because of the cage they're in, right? Because you don't have repeats in cages. So this cannot be 3 and 3. It has to be 1 and 5 in some order. We're not sure which one. What digit do we have here? And if you look at this zipper line, this shape is exactly the same. And it's also to a sum of 14. Now, if you take the lowest sums you can have, what are the lowest and the highest sums you can have for 2 digits in Sudoku with with unique digits? You can have 1 and 2 added together, which is 3. You can have 8 and 9 added together, which is 17. So if you go down from the highest digit, or the highest sum, and up from the lowest sum, you have 3 and 17 again. You have 4 and 16, 5 and 15, and then 6 and 14. Those are equivalent, essentially, for the low sums and high sums. So 14 is basically the same as 6 in the sense of if you look at the high digits and the low digits, right? Oh, and also, in this addition, these two digits cannot be 1 and 5, because if this is 1 and 5, that eliminates all possibilities for this cell, right? So this has to be the digits 2 and 4. So these are even. This must be similar, because you have a similar setup, right? It's exactly the same in the way that it's shaped, and you have also a gray square, which must contain an even digit. So these, again, must be 6 and 8. This is 6 and 8 equivalently. This must be equate to here, so this is... No, it must equate to here. This is 6 and 8. And it's blue. These both must be 5 and 9, and is odd. This must be 5 or 9, and therefore that must be 5 or 9, right? Or actually, this is 5, 7, or 9. And this is 5, 7, or 9. This is 5 or 9, 5 or 9. And this could be 5 through 9, 5 through 9 here. Well, similarly to how we saw 6 and 14, what's the next digit? Next sum that you can have? You could have 7 and 13. So this is equivalent here to 7 and 13. So these digits must be, it could be 4 through 9 here. And we know this is 4 through 9. And the 4, therefore, has to be one of these two digits. These are 1, 2, and 3. Therefore, the equivalent 9 has to be in one of these two digits. We also know, because of the 6, 8, 6, 8 pair here, that 6 and 8 cannot be in the rest of the column. So this cannot be 8. What is this digit? This digit cannot be 6 or 8 or 5 or 9 because it sees 6 and 8 by the two digits in the two cells in the same column with 6 or 8 required in it, and it has 5 or 9 in the same cage. So this must be 1, 2, 3, 4, and 7. Equivalently, this has to be, okay, so let's make that. This has to be an odd because of that. This cannot be 2, so it must be odd. This cannot be 1, 2, 4, or 5, so this is 3, 6, 7, 8, 9 here. Okay. Oh, we have a 2, 4, 2, 4 pair now, which eliminates 2 and 4 in the rest of the column. So this cannot be 4, 9. This can't be 2 or 4, which makes this an odd digit. And that must add up with another odd digit to add up to 6. So this can't be 2 or 4. We now have a 1, 3, 5 triplet in this box, which eliminates 1, 3, and 5 in the rest of the box. So this can't be 1, 3, and 5. This must be 2, 4, or 6. Well, these two digits must add up with these two digits to add up to 7. You have an even digit in either case here. This can't be 6, so this can't be 6. Where is the 6 then in this box? It has to be here, which means the equivalent one is here in this box, which is 1 to add up to 7. This cannot be 2, 4, or 6 because, again, an even digit with an odd digit must add up to an odd digit. If you have an even digit with an even digit, it adds up to an even digit, which 7 is not. Or an even number, sorry. So this cannot be 1 because of the 1 in the box. It cannot be 3, 5, or 6. Or sorry, it cannot be 2, 4, or 6. So it must be 3 or 5 here. So this is 1. So the equivalent here would be this is 4. And that's because this cannot be 2 or 4. So this can't be 4. This can't be... This 6 and 8... Where is this? Means this can't be 6 or 8, which means this is odd. This must be odd then also. So this 6 or 8. This can't be 5, 7, or 9. So this is 9, and this cannot be 4, 6, or 8, or 9. Because these two must add up to 13. Okay, what else do we have? These are all odd. One of these is even, the other one must be odd. What we have is a 5, 7, 9 triplet in column 4, which eliminates 5, 7, and 9 the rest of the column. This cannot be 7. So this cannot be 3 equivalently. One of these digits is a 7. Right? Because equivalently, one of these digits must be a 7. So because one of these digits is a 7, this cannot be a 7. Similarly, we have a 3 here because this must be 3 here. So this cannot be 3 here. We have the 5, 7, 9 triplet again, which eliminates 5, 7, and 9 in column 4, which eliminates 5 here. So since this can't be 5, this cannot be 1. Similarly then, we have 1, 3, 5 triplet, which eliminates 5 here. So this can't be 5, which means this can't be 9 to add up to 14. Now let's look at the 8 here. So the 8 can be 1, 7, 2, 6, or 3, 5 added to 8 to add up to 8. But the 6 cannot be here because this is 6. So this must be specifically 1, 7, or 3, 5. So these are both odd. This can't be 1, though. So this can't be 1. So therefore, this can't be 7. What possibilities are eliminated here? Actually, none of them are. Okay. We have a 6-8 pair here, which eliminates 1 and 6 here. Oh, that's okay. That was important, I guess. Which means one of these digits must contain a 3 or 5. Right? It's either 2, 5 or 3, 4, adding up to 7. Because of that, if you tried to have a 3, 5 pair here, that would eliminate all possibilities for the 7 cage. So this cannot be 3, 5. It must be specifically 1 and 7. This 1 means this can't be 1, so this is 5, which makes that 1 to add up to 6. This can no longer be 5 adding up to 6, so that means this can't be 1 adding up to 6. So we have a 3, 5, 3, 5 pair now in row 4, which eliminates 3 and 5 in the rest of the row. This cannot be 5, this must be 9, which makes this 5. This can't be 5, so this must be 7, which makes this 6 to add up to 13. So these are even. This 6 means this can't be 6. So it has to be 8, which makes that a 6, which makes that 8. This 8 means this can't be 8, so this is 6. Similarly, here, this can't be 5. So this must be a 7, 9 pair, which makes this a 5, 7 pair to add up to 14, which eliminates 5 here. This must be 3. This is 3 and 7. This is 3. This must be 4 to add up to 7. So that makes this 2, which makes that 4, which makes that 2. This cannot be 2 or 4 to add up to, or this can't be 2. So this must be specifically 3 and 4 to add up to 7, because there's no 2 possible here. So this is 3 and 4. That means these two digits to add up to 8 cannot be 3 and 5. It has to be 2 and 6. And this can't be 2, so this must be the 6, which makes that a 2. Equivalently, this must be 6 and 7 also. And this can't be 6, so this is 7, which makes that a 6. These two digits must be... So the equivalent, actually 11 is slightly different. Yeah, 11 is slightly different here. So this is actually going to make things different. So this is where it's not symmetrical around this. So these two digits must add up to 11. It could be 2, 9, 3, 8, 4, 7, or 5, 6. But 4, 7, and 5, 6 are eliminated because of the 6, 7 in the box. So this must be either 2, 9 or 3, 8. This can't be 9, so this can't be 2. And 3, 8 could be either one. So these two must add up to 11. So it must be 2, 9 or 3, 8 also. Well, this can't be 2, so this can't be 9. Everything else is fine. In this box has to be 5, 8, and 9 for the rest of the digits. In this box, it must be 1, 4, and 5 for the rest of those digits. Okay. What else do we have? 3s, 2s. Okay, the rest of column 3 must be 1, 5, and 7. But this digit can't be 1, so where's the 1 in column 3? It has to be here. So this must be 5 or 7. Well, this one's not similar because we don't have the restriction here, because this is different. We do know 9 has to be one of these two, because 9 cannot be here and 9 cannot be here. Which means 9 cannot be here. What are the remaining digits in row 9? They have to be 3, 8, and 9. This can't be 9, though. We know one of these has to be a 5 because there's no other place for the 5 in column 7. So this could be 3, 5, 8, 9, but no 9, actually. So it's 3, 5, or 8 here. Where is the 1? Oh, that's not helpful. Okay, so this 5 means this can't be a 5 here. So this is 3, which makes that 5. So, okay, that simplifies that. This 3 has to correspond to this digit to add up to 6, which makes that a 3, and that therefore that's a 1. So this can no longer be 1. We know this can't be 4, so this must be 2, which makes that a 3. So this is even, and this is odd. This 3 means that can't be 3, so this must be a 1. This can't be 1 or 3, so this is 2. This 2 means this can't be 2, so this must be 4. Oh, we already knew that, though. Okay. This can't be 5 because of that 5, so this must be 7, which makes that 5, which makes that 7. This 7 means this can't be 7, so this must be 9. Also, this 7 must add up with that digit to add up to 14, so this is a 7, this is a 9. This can't be 6 or 9 anymore, so this is 8. This can't be 8 or 9, so this is 7. This can't be 7 or 9, so this is 8. Which means this can't be 8. The digits remaining in column 5 are 1, 5, and 9. Well, this can't be 1 or 9, so this must be 5. This can't be 9, so this must be 1, which makes that a 9. So these are all odd digits. This is an even digit, even digit. This must be odd. The remaining digits in this can't be a 9, so this must be a 5, which means this can't be 5 here. We have an odd digit here. This is an odd. These are even. Odd, evens, and this is odd. These are odd. And these are odd. This is odd, and this is even. The remaining digits here must be 1 and 7. This can't be 7, so this must be 1, which makes that a 7. So these are both odd. The remaining digits in row 7 have to be 5 and 6, but they can be any of them. So this is 5 or 6. This 1 means this can't be a 1 here. The remaining digits in row 4 are 4, 6, and 8, which are all even digits, actually. There's no restrictions right now. This can't be 6, though, but that's it. The remaining digits in row 5 are 2, 3, and 8. This can't be 3, so this would be 2 or 8 here, which is even. This can't be, this has to be 2, 3, or 8, but there's no restrictions. Ah. Okay, the remaining digits in row 6 are 2, 4, and 6, which are also all even. So this could be 2, 4, or 6. This could be 2, 4, or 6 here. What we do have, though, is in column 8, we have a 2, 3, 8, 9 quadruplet. This is 3, 8, 9, 2, 3, 8, 2, 3, 8, and 3, 8, 9, which eliminates 2, 3, 8, and 9 from the rest of the column. So this can't be 2. That's it. That's all we got. That's all we got. Oh, this can't be 2 because of this 2 now. So this can't be 2, which means this cannot be 9. Well, we have a 3, 8, 3, 8 pair in the box, which eliminates 3 and 8 from the rest of the box, which means this has to be 2, and this has to be 9. Which means this cannot be 9 here. We now have a 3, 8, 3, 8 pair in column 8, which eliminates 3 and 8 from the rest of the column. So this must be 2. Similarly here, we have a 3, 8, 3, 8 pair in column 7, which means this has to be 9. This can no longer be 2. This can no longer be 2, so this must be 8. This 8 means this can't be 8, so that's a 4. This can't be 4 or 8, so this must be 6. This can't be 4 or 6, so this must be 8, which makes that a 3. This must be a 2, because that's the only digit remaining. This 8 means this can't be 8, so this is 9, which makes that 8. And the rest we can probably solve from normal Sudoku. So these digits have to be 2, 5, and 7. Well, this can't be 2 or 5 because of the 2 or 5 in the row, so this must be 7. This can't be 2 or 7, so this is 5, which makes that a 2. The remaining digits in column 1 are 3, 4, and 9. This can't be 3 or 9, so this must be 4. This can't be 9, so that's 3, which makes that a 9. That's 3 in the corner. We celebrate because we know we're getting close to solving this. This can't be 3, so this must be 8, which makes this a 3. This 3 means this can't be 3, so this is 8, which makes that a 3. This 4, that's 3 in the corner. We celebrate again because we're now really close. This can't be 4, so this must be 5. This can't be 4 or 5, so this is 1, which makes that a 4. This 4 means this can't be 4, so that's a 6, which makes that a 4. This 5 means this can't be 5, so the 6, and therefore that's a 5. And that's how you solve it. Pretty cool use of the symmetries, actually. I really enjoyed that. That was really fun there. And then this little small break in symmetry from the 11 to the 8 was actually quite interesting. I'm not really usually good at zipper lines, so actually I was kind of surprised that I did it that quickly, but this was just a well-constructed puzzle, so props to Mello Robinson on creating a pretty cool puzzle. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.